Hello all, today in this video I'm going to make an video for autoencoder from scratch with the MNIST dataset which is already present in the Keras library. So for that initially we are just declaring the libraries which we are needed like matplotlib, numpy, then TensorFlow. Import with the TensorFlow we are importing Keras and then we import TensorFlow as TF. Then we are declaring the variables like xtrain, ytrain and xtest and ytest by using the Keras library, dataset library. In that we are just loading the MNIST dataset which is a digit dataset, and then we are normalizing our xtrain and xtest value. Then we are making a definition to show the images, like a number of images we are setting it as 5 and then showing the images. And for that we are creating an iteration. The iteration will just call the number of images, and then it will show its image and what's its title, and then the title what is the digit it will just display. And then we are going to add noise to the images by making a noise factor and also declaring the extra noisy and extest noisy by using some uh, uh, equations. This code you may see in the previous video, that it will be made for only making how to make an noisy image in Python. So this is the same like that only. Then we are reshaping the images to and 784 dimensional vectors. And the what are the images we are going to, variables we are going to reshape or xtrain flatten from xtrain, xtest flatten from xtest, then the xtrain noisy image, and then the xtest noisy image. Then we are just showing our images, that is original image and the noisy image. You can see that number 5 is displayed as 5, 1 as 1, etc. Now we are just making the autoencoder architecture from scratch. Autoencoder architecture is more or less equal to an artificial neural network architecture. So initially we are making a sequential layer followed by some three dense layers which is considered as the encoding layer, and another three dense layers which is considered as the decoding layer. In the first dense layer we are making the size of the image which is 784. Here since it's we have given reshaped our image to 784, so we have given as 784. If we are reshaping to some different some other different sizes, means you have to give that size over here. Then 128 as the size, and then we are giving the activation as ReLU. And when compared to the second encoding dense layer, it is 64 and then activation is ReLU. Third is 32 and then activation is ReLU. When coming to the decoding layer, first one we are giving here, you can see it is highering and then lowering. Here you can see it is lowering and then highering. And so this is this code. Then we are just compiling our autoencoder by using the optimizers Adam, and losses we have set as binary cross entropy, and metrics we are going to declare also like accuracy. And then we are going to give a summary, like you have to get what is the shape and what are the parameters getting called in every dense layers. So that is called over here. Now we are going to train our model by using the dot fit function. So in that we are just calling the flattened layers, and then the noisy layers we are used in the noisy images we are using in the validation data. Shuffle we have called set as true, batch size 256, and it is going to run for 25 approaches. So you can notice that for every approaches the loss is decreasing as well as the validation loss, and also the accuracy is increasing and also the validation accuracy. So you may know that for a better system, when compared to the loss, the validation loss should be less, and when compared to the accuracy, the validation accuracy should be higher. So this shows that that is a system which we are a system or the model which we are defining as a best model. When compared with the 25th iteration, you can see when compared to loss and validation loss is higher than this loss, but mostly it's like that only. So in with accuracy also, if it is notice means but accuracy it is higher, so it is not a very well system. So we can change some modifications. Then we are making a plot to display the accuracy with the uh, validation accuracy, and also loss with validation of loss. You can see that it is wavering the, so both when compared to validation loss as accuracy, it is higher in some cases, that is in some approaches, but in some approaches it is lower. Likewise, when coming to loss, both are less, more or less it is same only. So it is not a good system, but at the same time it's not a bad system. So then we are going to predict so whether the output displayed from this model is providing better results and all. For that we are using the auto encoder function by using the predict and also the test noisy flatten images. In that, here we are going to images the number of images as 8 and then plotting it. And then for we are going to a loop. In that we are displaying the images, noisy images, and also the reconstructed images. So you can see mostly the prediction which is made by the autoencoder model, which we have defined from scratch, is providing better results only. You can see every numbers is declaring better only. So this is the code for autoencoder. In the next code we can see some other code. Thank you.